Welcome back to another explainer. So, I want you to think about this for just a second. What do calculating a weekly paycheck, figuring out a car's average speed, and measuring the flow of water from your kitchen tap all have in common? I mean, on the surface, they seem like completely different subjects, right? Maybe even entirely different sections of your syllabus. But dig a little deeper, and the math is exactly the same. Today, we're going to unlock a single, universal visual key that will help you absolutely master all of these concepts on your Cambridge Mathematics exams. Let's get into it.
Okay, so to kick things off, let's define what we're actually talking about here: a compound measure. Now, I know that sounds kind of complicated, but honestly, it simply links two different units together to give us a brand new rate. Think about it like blending two ingredients to make a completely new flavor. You could be blending volume with time or mass with volume, or even simpler, blending money and time.
To really ground this in reality, let's look at this example straight from our source material. We have Nyla, right? And she has a part-time job. Her rate of pay is $18.70 per hour. If she works for 15 and a half hours, how do we figure out her earnings? We just multiply her hourly rate by the number of hours she worked. So 1870 multiplied by 15 and a half hours gives her a solid $289.85. Boom! That is a rate in action. You just use a compound measure without even thinking about it.
Here's our quick roadmap for today. First, we'll look at everyday rates and flow, then speed and the triangle key. After that, we're applying rates to physics, followed by understanding population density, and finally, a quick key points recap. All right, section 1, everyday rates and flow.
So, here's a classic exam question straight from the source text. Imagine you sit down, open your paper, and you're asked, it takes half an hour to fill a 1,000-litre tank. What is the average rate of flow? First off, do not let the word average panic you. Just look at what we have. We've got two units here: volume, which is a massive 1,000 litres, and time, which is half an hour.
The absolutely crucial thing to remember here is that the average rate of flow is literally just the volume divided by the total time taken. That's it. Step 1, identify your numbers, 1,000 liters and 0.5 hours. Step 2, you divide that 1,000 by 0.5. And step 3 gives us our answer, 2,000 liters per hour. Just like figuring out Neela's paycheck, we're simply taking two units and comparing them. It really is that straightforward.
Moving on to section 2, speed and the triangle key.
Okay, you're going to want to pay close attention to this. Look at the DST triangle: distance, speed, time. This visual, it is an absolute lifesaver. Seriously, instead of trying to memorize 3 different algebraic formulas and getting them mixed up, you just use this one triangle. Here's the trick. Just cover up the quantity you're trying to find. If you want time, cover the t, and what are you left with? D over s, distance divided by speed. Want distance? Cover the d, and you're left with s sitting right next to t, which means speed multiplied by time. It's a total game changer.
Let's try applying that triangle right now. Finding the time it takes to walk 2 kilometers at a speed of 5 kilometers per hour becomes incredibly easy. We want time, right? So we physically cover the t. That tells us to divide our distance, 2 kilometers, by our speed, 5 kilometers per hour. That gives us 2/5 of an hour. But hold on, an exam might ask for that in minutes. So to convert, we just multiply that fraction by 60, giving us exactly 24 minutes. Do you see how the visual structure literally just guides you straight to the answer?
All right, section 3, applying rates to physics. Let's take it up a notch. Take a really close look at this pressure question. It says a 120 Newton box sits on a 50 centimeter by 40 centimeter base. Calculate the pressure in newtons per square meter. Now, this introduces a classic trap that catches literally thousands of students every single year. Do you notice anything a bit sneaky? They gave us the base measurements in centimeters, but they're asking for the final answer in square meters. We have got to always remember to check our units first. Step 1, change those centimeters over to meters before you do anything else. 50 centimeters is 0.5 meters. 40 centimeters is 0.4 meters. Multiply those together and you get an area of 0.2 square meters. Now it's exactly like our flow rate problem. Pressure is just force divided by area. So 120 newtons divided by 0.2 gives us a final pressure of 600 newtons per square meter. By structuring our approach and checking those units first, the actual calculation is an absolute breeze.
And guys, this brilliantly illustrates our universal key. Look at this. The speed triangle on the left and the density triangle on the right, they function exactly the same way. Instead of distance, speed, and time, the density triangle just swaps in mass at the top and density and volume at the bottom. The exact same cover-up rule applies here.
By comparing these formulas side by side, you can instantly see that finding the mass of a gold bar is honestly no more difficult than finding the distance a car traveled. Our source text tells us the density of gold is 19.3 grams per cubic centimeter. So if we have a volume of 30 cubic centimeters and we want to find the mass, what do? Just cover up mass on our mental triangle. We're left with density multiplied by volume. So 19.3 times 30 equals 579 grams. See? It's one mental model with endless applications.
Let's jump to Section 4, Understanding Population Density. Guess what? Population density is literally just another compound measure. It's just a way to measure how heavily populated an area is, taking the number of people and dividing it by the square kilometers they live in. Here's our source question. In a small town, 300 people live in an area of 2.4 square kilometers. Find the population density.
Using our trusted triangle method, it's a piece of cake. We simply take the top unit, the 300 people, and divide it by the bottom unit, the 2.4 square kilometers. Plug that into your calculator, and boom, we get our answer instantly, 125 people per square kilometer.
Once again, that exact same visual triangle method comes to the rescue for these demographic questions. Number of people goes up at the top, population density and area sit at the bottom. This just proves that our universal key works across essentially all subjects and question types you're going to face in your exam. Honestly, if you understand the triangle, you completely understand compound measures.
And finally, Section 5, Key Points Recap. Let's bring it all together.
First off, take a deep breath and just look at this quote directly from the Cambridge syllabus text. It says, "You do not need to memorize the formula for these compound measures, but you should be able to use them correctly." Guys, this is a massive relief. The exam is not testing your rote memory of a dozen different equations. It's testing your ability to recognize a rate and use our simple visual triangle to manipulate the numbers. I want you to take a mental screenshot of this table right now. Seriously, burn this into your brain. It's our ultimate cheat sheet for recognizing literally every compound measure you'll face. And here's the coolest part. Notice how the slash in the unit actually tells you the formula? Liters per hour literally means liters divided by hours. Newtons per square meter means newtons divided by square meters. The units themselves give away the answer. How cool is that?
So here is your bulletproof 5-step action plan. Number 1, identify the compound measure from the units you're given. Number 2, convert metric units if necessary, and watch out for that centimeter to meter trap we talked about. Number 3, apply the cover-up triangle visual. Number 4, calculate whether you need to multiply or divide based on that triangle. And number 5, always double-check your final units. If you follow these essential steps, you are going to extract maximum points from any rate or measure question they throw your way. With this visual strategy mastered, you've got a universal key that unlocks everything from physics to geography. So the next time you're staring down a complex exam question, just ask yourself, am I looking at a terrifying new formula, or is this just another triangle waiting to be solved? Keep trusting these visual systems, keep practicing, and we'll see you in the next explainer.